Hey guys, welcome back to Michelle's STEM Journey. I am Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2008 10A Problem 18 and it deals with algebra and geometry. I hope you all enjoyed this video and let's get started. The problem states a right triangle has perimeter 32 and area 20. What is the length of its hypotenuse? Okay, so in this problem, it deals with a right triangle, so I drew that out, and obviously not to scale or anything. But it tells us that it has a perimeter of 32 and then an area of 20. Okay, so let's set the legs to be A and B since we don't know what it is. And so right off the bat, we know that we can think of the Pythagorean theorem when we think of a right triangle. And so basically what the Pythagorean theorem is that it states that a squared plus b squared equals c squared, where a and b are the two legs, and then c is the hypotenuse of the right triangle. This only works on a right triangle. And so, because I already set the two legs of this right triangle to be a and b, then that's really easy. Then that means that c would be equal to the square root of a squared plus b squared. And we know that because we're just simply solving for c in this equation. So I can solve it out real quick by simply, if we're trying to find c and it is c squared right here, we can just take the square root on both sides, and the square root and the squared would cancel out, so c would equal to the square root of a squared plus b squared. So that's how we got that. But I'm just going to erase this really quickly. And so we are trying to solve for c, but in this equation we see that we have expressed c, and so if we do a plus b plus c, and in this case we solve for c as I just said, so we can substitute c with the square root of a squared plus b squared. This would be equal to 32. And that is because, as I said, these are all just variables, but we're representing each of the legs and then the hypotenuse with these variables. And so it tells us that we have a perimeter of 32, so we have that one equation. But we see here that we have one equation with two variables. And so that means that if we want to solve this, we want to get another equation with the same two variables, so we can have a system of equations to solve. And they also tell us that we have an area of 20. So if the area of a triangle is 20 and the area of triangle is 1/2 base times height. And in this case, we have the base is equal to b, and then the height is equal to a. And this is equal to the area, which is 20. And so we have a system of equations here, and we can solve for this. So we can first start out by rearranging the first equation and then squaring it. So for the first equation right here, I'm going to move over the a and the b. So this would give us I just moved that over. And then we see here that we have the square root of a squared plus b squared. And so what we want to do is that we want to get rid of the square root. But how do we do that? Well, as I said earlier here in the Pythagorean theorem right here, I did say that the square root and squared would cancel out on each other. And I'm just going to give a quick example right here. So if we have the square root of 4, this is equal to 2. But then if we didn't know that and we would want to square this, if we want to square the square root of 4, then we will have to square the other side as well. Because remember, what you do on one side, you have to do to the other side. And then so this and this would cancel out as I stated. So 4, and then 2 squared is also equal to 4. So that means that that works. So just to throw that out there. So we can square on both sides of the equation, which we would get a squared plus b squared. And in this question, there are a lot of places where you need to know some rules for just equations and squaring things. So here we have a special rule for when you square a binomial. And so basically, this special rule so the special rule is that if you have a plus b, and then the quantity of a plus b squared, that would equal to a squared plus 2ab plus b squared. And so that's just a rule that you will need to know, and it comes in very, very handy. But in this case, we have 32 minus the quantity of a plus b. And so if you have minus, it really doesn't matter. It kind of is the same here. So basically we just get 32 squared. Instead of plus, we have 32 squared minus, and then 2ab, so 2 times 32 times the quantity of a plus b. 2 times 32 is 64, and so it would be 64 a plus b, because you can't really do anything with a plus b, and we're not going to multiply n64 yet. And then we would get a plus b, the quantity of a plus b squared. And so basically, if you have a minus sign instead of a plus sign, then all you do is you have a minus sign and then a plus sign instead of having 2 plus signs. From now here, we are going to move over the 64 times the quantity of a plus b. So we're going to move this over. And so that would give us a squared plus b squared plus 64 times the quantity of a plus b is equal to 32 squared plus the quantity of a plus b squared. Okay, and then here we see that we have another squaring a binomial right here, and that is actually the exact same as the formula itself. And so we can apply that same exact rule to this, and so we would get 32 squared plus a squared plus 2ab plus b squared. And then we see that we have a squared plus b squared on both sides. And so all you have to do is we can move, I'm just going to change the color here. We can move over the a squared and the b squared. If we move that over, then that would cancel out, because we would get a squared minus a squared and then b squared minus b squared, because the signs will change when you move it over. And so we have a squared plus b squared, those out of the way. And that would give us just 64 times the quantity of a plus b is equal to 2ab plus 32 squared. Okay, this is a lot of work, and you have to really be meticulous, because one small mistake and you'll get a whole different answer. But moving on, and I'm just going to continue on this side, but we can divide the 64 over to just get out a plus b. And what we are doing here, and I'll explain in just a second. What we are doing here is that when we set a system of equations with just revolving around a and b, what we wanted to do is, it would be really hard to figure out what a is and what b is. And keep in mind that you don't always have to figure out what each variable is. If finding out what a plus b is or what a times b is, it would really help in other situations. But in this situation right here, by using the system of equations, we have come to a conclusion that a plus b equals 2ab plus 32 squared over 64. And we have an ab in the equation that we're trying to solve for. And then we also have this second equation that we have not used yet. Keep in mind that all of this comes from the first equation. We haven't used the second equation yet. And so we need to figure out what a times b is, which is perfect because we know that 1/2 times a times b equals 20. So if we just move the 1/2 over, we would get a times b equals to 40. And then so now we know what a times b is, we can plug that in to this, and we would get a plus b is equal to at plus 32 squared over 64. And so now it's just numbers. We got that a plus b is equal to 80 plus 32 squared plus 64, and so we can just solve for this side and then get what a plus b is. And so simplifying this, we would get a plus b is equal to 69 over 4. Okay? And just erase those two formulas just to give us some more space. But we now know that a plus b is 69 over 4. And looking back at the graph that we have here, we know that a and b are both the legs. And we're trying to figure out the hypotenuse. Now, if we know what the two legs add up to be, and we also know the perimeter, then that means that if we just subtract the two legs from the perimeter, we get the hypotenuse. So basically, we have 32 as the perimeter, and then we can subtract the sum of the two legs, which is 69 over 4, and that would give us the answer. Okay, and then so we would get 32, and then we want to find a common denominator, so we're just going to multiply 4 and 32 to get 128 over 4 minus 69 over 4, and that would give us 59 over 4. And that is the answer. That is what the hypotenuse is equal to. And then looking back at the answer choices, we get B, 59 over 4.